What's Gucci, everybody? It's AJ here again, and today I want to talk about bit operators in C. And this is a remake of a tutorial that I already made, or I guess a part 2 in my tutorial series, because I realized I was wrong about some bit operations. I make these videos as I learn things, and I realized the video I made about bit operations, there was something that is very wrong, that is very key to understand in the bit operations. So in my other bit operations video, I talk about the OR symbol, the AND symbol, the shift right symbol, the shift left symbol, the exclusive OR symbol, the complement symbol, and that's about it for bit operations. Now, what I want to talk about here is about I want to get more in depth about the shifting left and right. Now, what I taught you about the AND statement, the OR statement, and the exclusive OR statement is correct. But there are two kinds of shifts. There are logical shifts and there are arithmetic shifts. Hope I spelled that right. Arithmetic. So what logical shifts do is that if you shift it left or right, whatever spaces you shift it, those spaces will be filled in with zeros. But arithmetic shifts preserve the sign. So if you shift it, it will preserve the sign. So if it's negative, meaning a 1 is in the most significant bit, then it will fill in those spaces with not zeros but ones. And if it's positive, so the least significant bit is 0, it will look at that and fill it in with zeros, just like a regular logical shift. And this can be confusing sometimes. So let me show you guys a little example. I'm going to make an intro and call it Homer, after one of my favorite television characters, Homer Simpson, and I'm going to print F, %D. I'm going to print out Homer, but before I'm going to shift it to the left twice. And what that's going to do is that's the equivalent of timesing it by 2 to whatever I put as the parameter. So 2 to the 2 squared is 4. So this is equivalent as timesing 500 by 4, which will give me 2,000 when I run this. And it takes a little while, but as you can see, I have 2,000 bada bing bada boom. If I wanted to times this by 8, that would be 2 to the third. So I'll just put 3 here, and I get 4,000. Now if I wanted to divide this, I would get, I'd be dividing 500 by 8, which does not go in perfectly, I believe. So I will get 31. And so 500 divided by, 500 divided by 16 may be 31. Let's divide it by something I know. So let's do 32 divided by 4, which is 2 to the 4, which is 16. So hopefully this gives me 2. And it does. There you go, 2. So I'm doing, basically this is the same as doing 32 divided by 2 to the 4th. But now things start to change when I add in a negative number to these logical shifts. So as I taught you, these logical shifts work. Now I'm going to make this 32 negative 32. And when I shift this to the to the 4th, I will still get negative 2. I believe I will get negative 2, which I should get because it's negative 32 divided by 16, which is in mathematics negative 2. And we do get negative 2, which is good. But now let's watch. Let's say I make this negative 33. Now this should still yield negative 2. But I have a feeling that it will not, because it rounds down, divisors round down, see? And see, it yielded negative 3, which is not what we want. So the reason because of this is because when I am shifting it over, when I'm shifting over this negative bit, since it's 2's complement and 1 is the most significant bit, then the spaces I shifted over are getting filled up with 1s. And in the case, if what you're dividing it by or what you're shifting it by, 2 to the blank, 2 to the parameter, does not go perfectly into the number that you're dividing it by, you're going to get an offset error. Most likely, you're going to get it. You will get the answer you want minus 1. So I wanted negative 2, but I got negative 3 minus 1. And so this is something you have to account for. This is something you have to worry about.